Independence. I long to be free, free to pursue meaning and happiness in my own way, unfettered by the constraints of outside forces and necessity. With freedom comes responsibility, as we all know, responsibility for myself and for my impacts on everyone else. So to the extent that I am free, the meaning and happiness in my life are up to me to discover, define, and achieve. Yet paradoxically, I notice that what is most meaningful to me occurs in connection to others. Those I love, those who inspire me, those who make me laugh, or who I make to laugh, or who are improved by knowing me. Have you ever heard an awesome riff, or laughed at a dark joke, or learned something that thrilled your intellect, only to have the immediate bittersweet desire to have shared the experience with someone else? To have had someone else to be together with who would have been in the position to be impacted as you were? In previous episodes, I've explored morality and found that it is a social innovation, meaningless in solitude. Perhaps I long for independence not to be freed from society and its demands, but rather to reconnect to society in a new form, authentically, one that expresses more beauty, more truth. In this sense, I long to be free from the expectation to be a cog in a pre-existing machine, to take license to be an engineer. The cog grinds in contribution to the future, but the engineer reimagines what the future could be. In a very important sense, the universe is a single thing. Its contents are expressions within it, like wrinkles in a fabric or waves on the ocean. The wrinkle in the wave are alterations of their substrate, but not extra things in addition to it. We discover the wrinkles in the fabric of space-time. We measure and compare them. We learn about the nature of wrinkles. What can we say about the fabric itself, but that it is the hypothetical foundation for the wrinkles we discover? We infer from the wrinkles that there must be a fabric. Which is most real, though? The wrinkles which alter the fabric or the fabric which is altered? Reductionist reasoning insists that it is the fabric which is real. My qualifications for talking about the universe and its physical foundations are probably even less than yours, listener. I read, I think, I remain puzzled. I'm a neuroscientist, not a physicist. Yet even that qualification hardly ensures that I am positioned to make sense of the human mind. Nevertheless, that is my mission, and I choose to accept it. Consciousness, too, is a single thing. Its contents are expressions within it, like wrinkles in a fabric or waves on the ocean. In this way, the conscious mind is either analogous to a universe, or it is literally a universe itself. This unity presents to me a serious problem for the panpsychism that I'm beginning to see gain influence in the community. Let's consider the contents of the universe and compare them to the contents of consciousness. We have established that the universe might be one thing with localized expressions of properties within it. The fabric of the universe is space-time, and its contents are best understood in geometric terms. This is why we talk about dimensions. Thus, position and size and shape and motion are geometric characteristics of the universe's contents. Particles and waves, whatever they are localized in space and time. Einstein showed us that fundamentally matter and energy are instances of the same thing. But what thing? An elementary particle is characterized by only 3 true properties according to current physics: mass, charge, and spin. Any further properties can be derived from those 3. So what is an elementary particle then? It is a geometric point of massness, chargeness, and spinness. In fact, there isn't really anything particulate about a particle. The term is misleading. What we mean by size is an effect size rather than the size of the particle. The particle has no size, just an effect size. Does this imply that size isn't real? An atom has size, but as we know, most of it is taken up with empty space. It might be more accurate to say that it is only composed of empty space. Points of massness, chargeness, and spinness interact to form a structure and emergent properties of the atom, but each of the points takes up no space of its own. If we imagine the atom as a sphere with points in the center and points around the circumference, we can't have gone too far wrong. Each of the points is a disturbance in the fabric of space, not a piece of fabric itself. The laws of physics describe how these disturbances interact with one another. Most importantly, the points of disturbance coalesce into arrangements of great magnitude and consequence, planets and stars and galaxies and everything else. These things are but wrinkles in the fabric of space-time, a fabric which was shaken out of the Big Bang and which will ultimately flatten out to nothing again through the process of entropy. Like the wake of a passing ship formed on the surface of the water, its waves will grow and crash, and then weaken and disappear. We, the people of the universe, are but wrinkles upon wrinkles, destined to be ironed out of the fabric of nature without a trace. This next passage is from Lawrence Krauss's book, A Universe from Nothing. He wrote, quote, "While the details are complex, the general structure of Einstein's equations in general relativity is relatively straightforward. The left-hand side of the equations describes the curvature of the universe, and with it, the strength of the gravitational forces acting on matter and radiation. These are determined by the quantity on the right-hand side of the equation, which reflects the total density of all kinds of energy and matter within the universe." Einstein realized that adding a small extra constant term to the left-hand side of the equation would represent a small extra constant repulsive force throughout all of space, in addition to the standard gravitational attraction between distant objects that falls off as the distance between them increases. If it were small enough, this extra force could be undetectable on human scales, or even on the scale of our solar system, where Newton's law of gravity is observed to hold so beautifully. But he reasoned that because it was constant throughout all of space, it could build up over the scale of our galaxy and be large enough to counteract the attractive forces between very distant objects. He thus reasoned that this could result in a static universe on the largest scales. Einstein called this extra term the cosmological term. Because it is simply a constant addition to the equations, it is now, however, conventional to call this term the cosmological constant. Once he recognized that the universe is actually expanding, Einstein dispensed with this term and is said to have called the decision to add it to his equations his biggest blunder. But getting rid of it is not so easy. It is like trying to put the toothpaste back in the tube after you've squeezed it out. This is because we now have a completely different picture of the cosmological constant today, so that if Einstein had not added the term, someone else would have in the intervening years. Moving Einstein's term from the left-hand side of the equations to the right-hand side is a small step for a mathematician, but a giant leap for a physicist. While it is trivial mathematically to do so, once this term is on the right-hand side, where all the terms contributing to the energy of the universe reside, it represents something completely different from a physical perspective, namely a new contribution to the total energy. But what kind of stuff could contribute such a term? The answer is nothing. Unquote. Krauss explains that empty space is now understood to have a very small amount of energy, which accounts for the cosmological constant and the expansion of the universe. It occurs to me to consider that this residual energy spread evenly in space is a property of the fabric itself. Thus, nothing isn't really nothing after all, but something, a thin gruel of universal fabric. I have learned from Krauss and other physicists that pairs of electrons and positrons spontaneously appear in space for a very brief period before annihilating one another. This occurs with regularity in what we call empty space. Thus, it might be apt to think of emptiness in the universe truly as a universal fabric, the wrinkles in which compose everything of interest or value that we know to be in the world. Now that we have established some characteristics of the physical universe at the most fundamental level as a kind of fabric with wrinkles, I'll try to give a brief view of consciousness at its most fundamental level for comparison. Consciousness is a unified composition of contents. It is thus one thing and many things, like space-time with its contents. The contents exist from a unified point of view, mine in the case of my mind and yours in the case of yours. According to my theory, contents exist as the meaningful signal which we experience against a background of noise. We do not experience the noise. The noise is created by a massive amount of neuronal firing activity across a massive amount of the thalamocortical system. The whole system is highly integrated in that the neurons that make it up are sharing influence in both directions over a short period of time. That is to say, they are exhibiting both causes and effects within the whole system at some level. According to my theory, only that limited number of neurons within the system that is involved in a higher level of cause and effect at a given time over that of the whole system produce the signal that we experience as content. This ensures that what we see and hear and feel is the most relevant activity going on in the conscious brain. But notice the similarity to the model of the universe which we have sketched. The background noise produced across the thalamocortical system is the fabric of consciousness. Just as we do not find apparent contents in empty space, we do not find apparent content in the background noise of the brain. Rather, wrinkles in the fabric of consciousness are its contents. It is they that compose the phenomenal landscape. We can only infer that consciousness exists from the appearance and quality of its contents. And what of these contents? What are these qualia? Why are they like they are? The contents are exactly what it is like to experience the geometry of their substrate. They are meaningful in their relationship to other contents of concept and perception. This is not as outlandish as it sounds when you consider that the features of the universe are just expressions of properties, just waveforms of subatomic nothingness. The physical universe is filled with contents that are nothing more than relative occurrences. They are wrinkles in the fabric, and they are temporary. Likewise, the contents of consciousness are subjectively meaningful. They too are relative occurrences. In the physical universe, the wrinkles have powerful effects on other wrinkles. They are not a mirage, but real objects with real properties. They are real in that they exist when and where they exist. My experiences are real too. Whether the contents of the universe and the contents of consciousness are real is only a question when we take a radically reductionist, timeless view. Just as the universe will flatten out in eventuality, my conscious mind will disappear into the void. It does not exist independently of or in addition to the universal fabric. In my brief description of the fundamental physical universe, I mentioned entropy as the process which will flatten out the wrinkles we enjoy. What relationship is there between entropy in the universe and consciousness? Let's start by trying to get a handle on the concept of entropy. In his book, From Eternity to Here, Sean Carroll writes, quote, "We often say that entropy measures disorder. That's a shorthand translation of a very specific concept into somewhat sloppy language. Perfectly adequate as a quick gloss, but there are ways in which it can occasionally go wrong. Now that we know the real definition of entropy given by Boltzmann, we can understand how close this informal idea comes to the truth. The question is, what do you mean by order? That's not a concept that can easily be made rigorous as we have done with entropy. In our minds, we associate order with a condition of purposeful arrangement as opposed to a state of randomness. That certainly bears a family resemblance to the way we've been talking about entropy. An egg that has not yet been broken seems more orderly than one that we have split apart and whisked into a smooth consistency. Entropy seems naturally to be associated with disorder because more often than not, there are more ways to be disordered than to be ordered. A classic example of the growth of entropy is the distribution of papers on your desk. You can put them into neat piles, orderly, low entropy, and over time they will tend to get scattered across the desktop. Disorderly, high entropy. Your desk is not a closed system, but the basic idea is on the right track. But if we push too hard on the association, it doesn't hold up. Consider the air molecules in the room you're sitting in right now, presumably spread evenly throughout the room in a high entropy configuration. Now imagine those molecules were instead collected into a small region in the center of the room, just a few centimeters across, taking on the shape of a miniature replica of the Statue of Liberty. That would be unsurprisingly much lower entropy, and we would all agree that it also seemed to be more orderly. But now imagine that all the gas in the room was collected into an extremely tiny region, only 1 millimeter across, in the shape of an amorphous blob. Because the region of space covered by the gas is even smaller now, the entropy of that configuration is lower than in the Statue of Liberty example. There are more ways to rearrange the molecules within a medium-sized statuette than there are within a tiny blob. But it's hard to argue that an amorphous blob is more orderly than a replica of a famous monument, even if the blob is really small." Unquote. Sean Carroll has helped us to see that our intuitions about order and disorder might not do a good job of revealing the meaning of entropy. Of course, we know that human cognition is not well adapted to thinking accurately about probabilities. I see this as a limitation of imagination more than a limitation on the accordance between entropy and order. But his point is important and comes with my appreciation. It seems worth specifying what is meant by entropy a little further at a finer scale. Carroll writes, quote, "For the time being, let's recognize that the association of entropy with disorder is imperfect. It's not bad, it's okay to explain entropy informally by invoking messy desktops, but what entropy really is telling us is how many microstates are macroscopically indistinguishable. Sometimes that has a simple relationship with orderliness, sometimes not. There are a couple of other nagging worries about Boltzmann's approach to the second law that we should clean up or at least bring out into the open. We have this large set of microstates which we divide up into macrostates and declare that the entropy is the logarithm of the number of microstates per macrostate. Then we are asked to swallow another considerable bite, the proposition that each microstate within a macrostate is equally likely." Unquote. So we are confronted with this business of microstates and macrostates. Let's consider this in brief with a mundane example. Suppose you're playing Yahtzee. You have 5 regular dice, and let's suppose that you need to get 3 of a kind. There are many ways to get 3 of a kind, and with 5 dice, the odds are not so difficult to calculate. I'm not saying the odds come swiftly to mind of an average person, just that 5 variables is a hell of a lot fewer than billions of molecules of gas bouncing around to space. In the example of the 5 dice, the result showing on each die is its microstate. The macrostate is the result of the 5 dice together. In agreement with Sean Carroll's points on entropy, there are more ways to not get 3 of a kind than there are to get 3 of a kind. Thus, the macrostate of 3 of a kind is less likely than all the other possible macrostates put together, and we can expect if we repeat this experiment by rolling the dice again and again, we will more often fail than succeed. Also, in agreement with Sean Carroll's points on entropy, we see quite clearly that each die is equally likely to turn up each of its faces. Now let us compare this to the melting of an ice cube in a glass of water. There are millions and millions of water molecules in the cube. Each molecule is more likely to dissociate its bonds under these conditions than it is to form new bonds. If more molecules dissociate from their colleagues, then the ice cube is melting. If more molecules cling to their colleagues, then the ice cube is growing. We see if we run this experiment upon our dining room table that the ice cube is melting rather than growing, and we would be suitably surprised to discover the opposite result. If we could calculate, given the temperature and pressure and all the rest, the likelihood of each molecule to cling or to let go of its comrades, we would see that this is in perfect agreement with the remoteness of the ice cube growing. For our purposes, let's have it be 1 in 6 in favor of forming new bonds with other water molecules. 2 things become immediately clear. First, rolling 10 million dice and getting more than half of them to show a number 6 is not going to happen in the real world. But secondly, rolling 10 million dice and having the majority show 6 is not impossible. Likewise, the gas in your room might, in the next moment, inconveniently evacuate to the space under your bed, but I wouldn't hold your breath. So all of that is going on in the physical universe, and it manifests in the model I proposed of fabric and its wrinkles by demonstrating that the fabric as a whole was once more wrinkly than it is now, and will ultimately lose its wrinkles altogether. New wrinkles will appear, but less frequently than old ones will disappear. The wrinkles are macrostates, while each little fiber of the universal fabric is in a microstate. The wrinkles are in this way emergent upon the fibers. Fine. What about consciousness? I am endeavoring to compare the conscious mind to a universe. I said before I went off on this tangent about entropy that the contents of consciousness are the wrinkles in its fabric. We do not experience the fibers. Thus qualia are necessarily macrostates, not of the fibers of consciousness, but of the fibers of the physical universal fabric. Like the solidity of a table or the wetness of a pool of water, they are emergent properties, but these emergent properties are subjective. Thus it seems that in one common universe there are emergent objective properties and emergent subjective properties. These are wrinkles within wrinkles in the universal fabric. How could such an organization come about? We already know the answer in broad form. It evolved. But what about the second law? How can something more and more ordered come to be in an arrow of time that guarantees the opposite? Quite simply, it couldn't if the system were closed. If life were sealed off in an opaque room, then its project would be foreclosed. But we, the life forms of Earth, are by no means enclosed in such a system. Rather, we are bathed in the energy of our sun. You and me, the minds of modern man, are the unlikely outcomes of remote rolls of the dice. But this is no miracle. After all, the dice were loaded.